We have 2 new people on our team, Jen and Bob. So we're trying to. So if you want to work with us, you have to shorten it one syllable. So anyway, we're going to be talking about data pipeline foundations for production. This is a topic that interests all of you. If not, just keep enjoying your sandwiches and we'll. So why this talk? So companies are trying to execute data science projects without setting proper foundations. Does this sound like a familiar problem? I'm going to show of hands. Like, so the result are typically like flimsy data foundations and failed data projects. So this isn't uncommon, as we'll see in a second. This is actually extremely common. It'll be addressed. So the main takeaway we want you to think about in this talk is like think pipelines first, right? Data pipelines.
Yeah, so I think this is kind of a new abstraction since I've gotten into the data industry. So I think maybe 7 years ago, people would talk a lot about what the cool new technology is. Oh, I just recently discovered Redshift. I recently discovered Hadoop, whatever that technology was. And our opinion is that in the modern data ecosystem, especially as you're moving into the cloud or into, if you're on-prem, and into virtualization, you want to think about kind of all the tools at once and just use the most appropriate tool for the job. And you want to think in terms of a high-level abstraction of pipeline.
So a bit about Ternary Data, our company. We're jokingly call ourselves recovering data scientists. So, and we focus on training and enabling companies to build robust data architectures. We're a data architecture consulting firm. We are heavily involved in the local data community. Quite a few people here. Hello. And this talk is near and dear to us. This is kind of why we started this company in the first place. How many people have seen the data science hierarchy of needs? So we sort of ad-libbed on it. Originally, it was just a pyramid without my lame script. But really, everyone, people want to focus on the top, AI, deep learning. That's the cool stuff, right? That's what data science is supposed to be. Unfortunately, what usually happens is all this is ignored here. So data pipelines, even analytics. It's shocking how many companies aren't doing analytics, yet jump straight into AI. And I don't. So and then at the bottom, we come to find out, well, people are kind of important too, actually. You need to get executive buy-in, you need organizational alignment, and other things. And this arrow is supposed to say it's a problem. It's another thing we noticed. We actually, one of our clients had hired one of Matt's classmates as a data scientist and PhD in math, and then they come to find out they had no problem for her to solve.
So like data science is not magic, right? If you can't identify a business problem, then you're probably not going to get much out of your investment.
Yeah. So anyway, so we sort of think in terms of this continuum here of like, foundation, data foundation, pipelines, analytics, and, stuff like that now. So the result most people run into is this. This is the data infrastructure that a lot of people are having. So, it's brittle. It'll probably. I mean, I don't know if you'd want to live here if you do whatever production mode, I guess. But what happens is you have a lot of wasted time and a lot of wasted money, right? And then you have a lot of frustrated people in your organization who then start discrediting data. Well, we already tried data science. This isn't working. It happens a lot. Some stats real quick. So Gartner, they had this stat, what was it? The 60% was in 2016 or 2017. They bumped up recently to 85% of big data projects fail. So either end of that range is still pretty unacceptable, right?
So the result of a big data project.
What's that?
Are those numbers the result of a big data project?
Yes, it has a recursive feedback loop on itself. So. Yeah, but I mean, that's think of it, the amount of money and time that's invested into these kind of projects, though, and a lot of effort. A lot of I wager a lot of people here work on big data projects or just data projects, and so you imagine putting in a lot of your blood, sweat, and tears into something, and then it doesn't go anywhere, right? That kind of sucks. But it's even better than that. So Gartner also says 80% of AI projects will remain alchemy run by wizards through this year. I think it's probably going to be longer than that. So, but if you're a wizard, this is a really good place for you to be. So we like wizards, and so should you. Beat had a fascinating article where it was 87% of data science projects ever make it into production. So think about that for a second. They exist. Most data science projects we see are stuck here. Sorry, in a Jupyter notebook or something like that, right? So they don't really ever leave the laptop. And so you gotta wonder, if they're not leaving the laptop, then what value are they providing to the business, right? I'll leave it up to you to decide. So 100% chance there will be more stats like this in the future.
So we're going to talk about this concept of pipeline first data engineering. We already had a slide about that. Just in the back of your mind, for all of these concepts, think about how they fit into the vision of data pipelines and architecture, and defining the large architecture that can deliver value for the project you're working on. Number two, we'll talk about ingestion and collection. And I think if you've worked as a data engineer or data scientist, you kind of understand this is actually a really, really hard problem. A few years ago, people thought that having APIs and that we solved the problem. Turns out that that was not necessarily the case. Then we're going to talk about storage, and storage will encompass object storage and databases, and how you want to think of those in the context of your data pipeline. And we'll talk about the transform step. And it's funny, like transform used to be the key piece of data pipelines. I think 20 years ago, we talked about ETL, that's mostly concerned with, but the way we see it these days, it's just one of these key pieces of the puzzle when you're thinking about the whole machine learning pipeline. And then we'll talk about the do something part, and that includes the really tough ML engineering, where you're actually training deep nets and deploying models. And then we'll talk a bit about orchestration, and orchestration is one of my favorite topics, because when you hire a bunch of data scientists and maybe some data engineers, what inevitably happens? Well, workflows happen organically, and it gets very, very ugly very quickly. And so we'll talk about some solutions to that problem, and how orchestration is kind of the glue for all of these other pieces. And then Joe will be talking some about teams, which is this key aspect that often gets overlooked. If you can't solve your team problems, then you probably can't solve your engineering business problems. And we'll just talk about some general best practices and take questions at that point, and just general discussion. I think a lot of people here have a lot of insights to share from their actual practical experience in this area. We're not going to get too much into, so I apologize for this part, because this is supposed to be an ML meetup, right? But we're not going to get too into the details. Really, we're talking about kind of the enablement architecture that stands around machine learning, and how to automate a lot of processes, so you as a data scientist or machine learning engineer can basically produce more value for your company or the jobs you're doing.
Yeah, so I don't know if you can see that at all. This is actually on LinkedIn the other day. I sort of agree with him, sort of not, but I think the point really is, I don't know if we can read this or if you have time to read it, but basically, data science is more than just spinning up Jupyter notebooks at the end of the day. It's a great start, but at the end of the day, something needs to happen with it. So, I mean, the point of this thread was really, well, I mean, maybe you should learn more skills, Kubernetes, continuous integration, and so forth. I mean, the broader point is that think in terms of orchestration, think in terms of pipelines, think in terms of enablement, right? Don't just stare at Jupyter Lab and consider that's the end-all be-all. Maybe it is actually, but there's a lot more that you can do. So pipeline first data engineering. Pipelines, how do they work?
People got the reference. I didn't get that reference.
Yeah, who got the reference? We'll explain it to you later then.
Right. Okay, so this is going back to the earlier slide where we give a list of topics. This is kind of how we envision all the steps of your pipeline going. And I'll explain a bit why this transformation arrow overlaps these other two. But this in itself is a hard data engineering problem, ingestion. Storage is not as hard as it used to be, and we kind of suggest that you focus on other pieces of this. You got to get the storage right, but this part is increasingly commoditized. This is really tough, and this is really tough. And then this part might be the hardest of all, the orchestration layer. so overall goal here is this collaborative aspect. In terms, from a team's perspective, I think what we've seen is that even where companies have existing data engineers, there's a big disconnect in number one. Somehow the data engineers are not communicating with the data scientists. And what we'd like to see in the future, and even now, is that they're building the pipelines together. They don't work independently. They're both looking at the same pipelines and flows. Data engineers deliver new data sets as data scientists need them, and data scientists find out from the engineers what data is available and help them to design the pipelines they need.
Well, there's another thread on this. Yeah, what's up?
So where I work, we don't really have the separation of data scientist and data engineer. It's kind of like a full stack or whatever you want to call it.
Yeah.
Can you define where data engineer ends and where data scientist begins? I don't really know what data engineer is.
I can kind of like give you a smart alecky reply to that. So like there's an old kind of cliche saying now that data scientists spend 80% of their time cleaning data and processing data. So that's the 80%, that should really be a data engineer doing that part of the work.
Yeah.
And pipelines and everything else, right? So it would be everything that is
Making it accessible and clean.
yeah, like the job you were hired to do as a data scientist. I'm sure that job description maybe included data cleaning and pipelines. But it really, in my opinion, shouldn't. It should really have segregated. Now, I want to make a quick note on the data engineer piece, though, because I was thinking about this a lot today. We're at a client where the software engineers and the data engineers also need to talk, right? Because the software engineers sit upstream, and then the data goes down to the data engineers. And then it got me thinking, well, okay, so this is an interesting paradigm that also needs to be forgot to put in here. I'm going to write a blog post on this at some point soon. I think that in the future, you're actually going to see, as applications become more data native, and data is a first-class citizen, the delineation between software engineer and data engineer will become, I think, a bit more combined, so to speak. So
let me ask you guys, though, how many of you have seen data quality issues because software developers are not communicating with data engineers or data scientists? Yeah, a lot of hands, okay. We see it again and again with our clients. So someone's building an application, they're using Java and ORM, and so the data just gets mapped automatically in the database, and they don't really think about the fact that someone's consuming that for analytics, and so they change a field, and it breaks a report somewhere.
yeah, that happens. And the other one is when you have like somebody writes a Rails app using a CRUD database or CRUD paradigm, and then the records get updated or deleted, and you don't have a chain of events that actually happen with the data. This should make comments on that. Anyway.
So let me just loop back though, to the way I see the differentiation between data scientist and data engineer. From my perspective, a modern data engineer is more of like an architect. And so they want to see the whole pipeline. They want to see where things are flowing and what tool, kind of the holistic view of what tools are being used. Whereas the data scientist should also have some understanding of architecture, but should be focused on models and how they're getting business value out of those models. And then there's communication back and forth so that the data scientists get what they need, and the data engineers aren't operating independently. They're getting a lot of guidance for how to create that architecture that serves the business.
And on top of that, too, is share data assets, automation, collaboration, and then reduce the time to value for the data scientists. Really, like data scientists shouldn't be waiting on data.
And that's where having that communication comes in. We frequently see cases where data scientist asks for a new field in the database, and it's in the source data of the API, it's not being pulled. And they'll get quoted a time of 6 months. That's not great for your business, right? If it takes 6 months for you to just get that data, your time to value might actually be a year or something like this.
Yeah.
And so more flexibility and agility and communication can really improve that workflow. In some sense, it's like what agility did for software development. We want to see the same thing in data. Okay, who has dealt with issues with data ingestion and collection, in particular, say with APIs? Has anyone had problems like that? Yes. Yeah, anyone so enterprise 20 years ago was kind of a silo, right? You had your business and you had your business databases, you had this huge Oracle data warehouse, and maybe some of your partners, customers sent you some reports. But what happens these days? Well, you're no longer advertising in magazines necessarily. You're advertising through Google AdWords and Facebook. And you collect analytics from Adobe Analytics or Google Analytics. All of that data has to get from the outside world into your company. And that's a really hard problem. The world is extremely heterogeneous, and data engineers in practice have to spend a lot of their time figuring out how to connect to all these different data sources. As it says here, it's a cloud world. So cloud in the sense now that you're thinking about the entire internet basically is your data. Data can come from anywhere and any third-party vendor.
And IoT. So.
And the problem keeps getting worse, right? Like there's more and more data coming from the outside world that you need to think about as a data engineer and data scientist.
So, I mean, there's still sort of the paradigm of batch or real time. I mean, I think for Matt and I, our opinion is everything is eventually going to be streams, whether you like it or not. I mean, essentially data is, if you think of it as in a bounded or unbounded context, data is essentially all just unbounded anyway, right? If we put artificial delineations on whether, like, when events happen and start and end and whatnot, but really data just flows regardless. So I think the notion really is like, batch is a really convenient construct to think about data, and I would urge you to still keep thinking about this because that's, most tools just play more nicely with batch data. So, but what you're increasingly starting to see is the notion of a data river, right? You've heard of data lakes. I mean, that's great, but I think the world's starting to move even beyond that paradigm, right? Think in terms of continuity of events and what you can do with these events. That said, you always need to keep in mind, like, well, if I get the data in real time, like, what am I going to do with it anyway? Like, what action can I take? So, you know, my recommendation on this is like definitely, you know, if you can set up streaming pipelines using something like Kafka or whatever, or Pulsar, ingest that data, and if you're not going to do anything with it, put it into cold storage, and you essentially just have your data stored anyway. But in most cases, I think batch is pretty adequate. Now, I can foresee a future very soon where that becomes less and less the case.
And I think fundamentally, when you're thinking about batch versus real time as part of this overall paradigm of ingestion, avoid getting hung up on the buzzword, right? Like we'll see carrot cases where the CEO gets really excited about real time, and they go to their DBAs and like make everything real time. Well, if anyone's dealt with real-time data, it is very complicated, and this is a recipe for a lot of expense and a big-time failure. At the same time, the flip side of that is that almost every business has some real-time use case where the business would be helped by being real-time. And so identify something that's really going to help your business and make that real-time. And then you might find other use cases later, and the other stuff for a while, probably just stick with that.
Well, especially when you're dealing with like transactional data from databases, right? So MySQL, Postgres, those sorts of things. It's not that hard to set up change data capture on these databases. I would highly suggest doing this because at least then you have a log of how records mutate over time, right? Bobby Caldwell gave a fantastic talk at our data engineering meetup last week on CQRS and event-driven systems. I thought it perfectly captured where application development is going, where actually the events are just written into the application itself and maybe bypass a database. But the reality is most companies have databases, and I don't think those are ever going away. I mean, at the end of the world, we'll be cockroaches and transactional databases. So, but
Facebook will still be running.
Facebook will still be running somehow, yeah. But the notion is like change data capture can at least help you capture some of the events, right? So you have a record of how things are changing in your data. I mean, the classic conundrum is when you're building a data warehouse, right? How do you typically deal with changing data? It's like slowly changing dimensions and whatnot, but that's only as good as the data is being updated and pulled into your system, right? So if that's once a day, you may lose fidelity for the prior period that you're capturing. So CDC is, I think, a really good option here. But again, batch, not a bad idea. You got to start somewhere. So.
Okay, and this, I guess what I want to emphasize with this list, we broke this out into some real-time and batch tools that we see quite a bit. But one thing I'll point out here is that a lot of these can go on either side. And that's one of the nice things about the way data technology is evolving. Many of these tools can be run in a batch or real-time mode. And that means that if you start with that tool, you can start in batch, and then when you identify the right business value, you can switch over to real-time for that specific use case. It's actually data flow. Google specifically developed to solve the problem of the separation of batch and real-time. It does both on the same programming model. So you could basically take the same code and process a stream or process batch events. Spark is another one. Spark originally started out as strictly a batch processor. Technically speaking, it's real time, it's micro batches, but for practical purposes, it's real time. And so it can definitely move as well. And then as Joe was pointing out, a lot of these other tools, you can think of as batch ingesters. You can just take them and dump your data into an object store if you need to.
You're starting to see, I think all the clouds are starting to kind of center around batch in real time. I mean, Azure, for example, I mean, they have Data Factory, and that's pretty cool. If you have like SSIS jobs, by the way, and you don't really want to figure out how to untangle yourself from that mess, you can just ingest it into Data Factory and just upload all your problems to the cloud. So
that's interesting phrasing. Okay, the thing I want to emphasize with storage, going into this section, is this. Really, I would say in 2012, 2013, Hadoop was a really hot commodity. People worried a lot about creating these clusters to process large amounts of data. But what's happened since then? Well, something called, we call it the big data warehouse has emerged. And the big data warehouse is basically an analytics database that can handle big data scale, and you mostly don't have to manage. So there are a bunch of different examples of these. Redshift, BigQuery, Snowflake, Synapse Analytics on the Azure platform. Like, there are tons of these options. And generally, we recommend that you just use an off-the-shelf option rather than trying to work it out yourself.
yeah.
It's treated as a commodity.
So especially for structured data. I think back a few years ago, the notion was, oh, we'll put all of our data into a data lake, whether it's structured or not. But recently, I would say the modern data warehouses you can consider to be kind of data lake 2.0 or whatever you want to call it. I mean, it makes a lot more sense. The storage is actually cheaper in a lot of cases, and I would argue better. That said, you still have a lot of options if you wanted to go the data lake route. You have Parquet, Orc, Avro, knock yourself out. Especially if you're going to integrate yourself in the cloud, I mean, it's best to kind of do things the cloud's way that it wants you to do things rather than try and fight it.
And so fundamentally, basically make some choices about what your storage is going to be, what your big data warehouse is. You'll probably want an object store like S3 or Google Cloud Storage as well. Just like Joe was saying, because some data just doesn't fit into a warehouse, it's not structured. Okay, and these are some examples of how you make that differentiation. So there's increasing crossover between these two, honestly. We see a lot of semi-structured stuff that just...
Yeah, and the interesting thing in this one too is that the federated queries to a data lake. So I mean, you can essentially consider that, you know, with the modern data warehouse, you can actually just query any of these compression formats, except for Arrow, into your data warehouse anyway. So I think it's really a usability and business decision. Like, how do you want to separate your compute from storage and data from whatever. So some of these also, I will say, like, again, we talked about real time, right? Like, some of these data warehouses do accommodate streaming now. So some better than others. If it's a column store database and you have to do joins, don't expect that you're going to get great streaming performance out of your databases because of the way it's architected. Right? I would say something like Druid or Pinot might be a good option if you're looking for just straight real-time operational analytics. We need like sub-second queries, sub-millisecond queries even. If you need that kind of performance, I wouldn't mess with any of the first 4 options yet. They're improving, but like, we're talking to one company, and they were doing like live updates, streaming updates into Redshift, and then they're like, our cluster keeps shutting down like every 4 times a day. Like, it's not really made for that, but you know, so.
But on the other hand, like BigQuery and Snowflake will play fairly nice with real-time data as long as you architect this data.
Yeah, as long as you stay within the limits of them too. So. This was something that was on Hacker News the other day. How many people read Hacker News? Really? Oh, okay. a couple fans here. Great. So, but there was a really interesting discussion on modern data lakes, and it was fascinating getting the read on it. Because if you read Hacker News over the, I would suggest you do. It's a great collection of, I think, really intelligent articles and really intelligent commentary on these articles.
And a lot of trolling.
And a lot of trolls, some really intelligent trolls too. So you get, it's the best of all worlds. But I thought this was a pretty fascinating take on data lakes. I'll just let you go ahead and read it. So again, I mean, it's a popular notion. I think we still see people going the data lake route. And again, if you're dealing with unstructured data, I don't know how else you're going to do it. You probably need object store. But if you're doing the structured data, think twice. I think nowadays it might overcomplicate things, honestly. And then the pattern that we're seeing really is like ELT, so extract, load, transform, not ETL. So just load your data into a staging area in your data warehouse, your structured data, and then just have your way with it from there.
And I guess the real point here is that there's no technology magic bullet, right? So I think there was a lot of promotion around data lakes for a while. There was this idea like, just dump everything there and then magic will happen. Like, poof, you'll get some value out of it. Well, the truth is that with data lakes, the ETL, or at least let's call them transport pipelines, to use the terminology we like, transport pipelines become more important than they ever were before because your data is actually much more complicated than it was in a data warehouse. To get the value out, it has to be processed and refine.
Well, yeah, and the other part of it is it's hard to query. I mean, it's harder to query data lakes unless you're using like Spark or something on top of it, right? Or using federated queries, and especially with compliance issues now, right? Where GDPR, you have to delete data, or like CCPA, this becomes kind of an issue. And how many people have heard of the term data swamp? So, yeah, these spring up a lot. And so, you know, because the notion is you can throw everything in there, which means human nature is, we're all lazy, so we'll just throw everything in there, and you'll forget what's in there. And like, I can't even count how many times we've seen people forgetting what S3 bucket does what, or like what's in there. So you don't want to delete it. So it's worse than like those hoarders show you see on like HGTV, where like, you know, you walk in, it's like, oh, I can't throw that piece of bread out because it's been there for 2 months, and like if I throw it away, I don't know what's going to happen. Like that's people's data lakes. It's crazy. So if you're into that kind of stuff, then go knock yourself out with that. Transformation. So
yeah, so I think our main idea here is that if you're in the cloud, you can just use the right tool for the job. You don't have to have, you want to decide on maybe a big data warehouse as a core, but you can use a lot of different tools around that. And so really that means that you shouldn't get so excited about Spark that Spark is the only tool that you want to use. Use Spark when it's the right tool for the job. Use Apache Beam when that's the right tool for the job. Use Presto for some jobs. At the same time, to totally contradict what I just said, don't overcomplicate your life. Don't just use a tool because it's shiny and new. Make sure that it actually does something that's valuable to you if you're going to adopt it. And in general, again, if you're in the cloud, use managed services. You as either data engineers or data scientists increasingly want to focus on that high-level picture of how to get that value from your data. And so that means that you probably don't want to be managing your own Hadoop clusters on EC2, for example. Just let Elastic MapReduce take care of that and then burn them down when you're done and create new ones. And then this last point is near and dear to my heart. Orchestration is the most important piece of all this transformation. If you don't think about orchestration early, then you end up with a huge mess. Maybe call it a task swamp or something, because I've certainly seen things like that.
yeah, I like that. Yeah. So watch out for the hammer and nail syndrome. As you mentioned, Spark, right? Like that came into the scene around 2014. Everyone thought it would be like the panacea for all data problems. It can do a lot, but since then, I mean, the pace of innovation in data tools is amazing, especially in the transformation area. Actually, it's like I can't even really keep up. I've stopped trying to keep up. Actually, well, not really. That's a total lie. I keep up, but I mean, there's just a lot of things to pay attention to. There's always new paradigms for transformation. And now it's like there's some arguments that, well, transformation just happens at query time, and you don't save any artifacts of the transformation. Whatever works for you. But the notion really is like one tool isn't going to solve your job. So again, back to the word heterogeneous, right? I'd say that the transformation toolscape is such, like, figure out what works for the specific task at hand. Use managed services. Avoid rolling your own. So this is,
This is vaguely inappropriate.
whatever. But this happens a lot. So we've seen people like write frameworks, like transformation frameworks, when there's like readily available stuff on the shelf. And there's like the open source world is full of tools, transformation or otherwise. So some examples, if you want to go code heavy, Beam, Spark, and even, we're starting to see people just doing the transformations within the data warehouse itself, actually. Again, ELT. BigQuery Presto is a really big one, Redshift, for example. There's managed services like Databricks and Kaggle that'll package a lot of Spark, Presto into one place. Glue is another one that's just basically managed Spark along with the data catalog in AWS. Dataflow, we talked about, and Data Factory, which is actually just runs on top of Spark. So it's kind of the question, do you want to roll your own Spark or do you want to use their Spark?
One thing I'll say here is that a lot of your job as a modern data engineer is to do cost engineering. So we think about performance engineering, right? So I have this hardware cluster of 100 nodes, and I need to tune it to get maximum performance out of it. Well, if you're using services and you're using the last MapReduce or Databricks, you want to think about how to tune for how much it's going to cost you, your company, right? When you see stuff that's really expensive, you need to cut the cost down.
But the cost equation is an interesting discussion, though, right? How many people have heard of total cost of ownership? There's also total opportunity cost of ownership. I want you to think about that concept for a second, right? You get too embedded in a technology and your entire workflow is like rigid and inflexible. Well, now you just lost the opportunity to experiment or enable new technologies. You see this around quite often where you're stuck on a 10-year-old technology and your chance of getting off of that in the next 10 years is probably, you're better off starting greenfield, honestly, starting over in some cases. So I mean, that's the reality of it. So you got to be really careful because like you said, cost is one thing, opportunity cost, I would say, is almost equally as important in this picture. So.
And the other thing to take into account, using managed services, they may look more expensive, but I think what we saw happen in the Hadoop world is that everyone went into Hadoop thinking it was going to be really cheap. And then it turned out that when they were buying their own servers and managing them themselves, a lot of these companies ended up spending $1 million a year on personnel just to manage that cluster and handle updates, and then you write the occasional job. And so using a managed service both gives you more flexibility for better opportunities. And yes, there are costs associated with those managed services, but there's also a lot less management for you to handle.
Yeah, and a lot less like digging out of your problems too. Like how many people have heard of Pig? Yeah.
How many of you have used Pig? How many of you have debugged Pig crashes where you can't find the problem because it happened on some?
Yeah, that's what's up. So yeah, SQL. So it was kind of funny, like back in the early MapReduce days, Java was still the first class citizen, and you would write all your MapReduce code in Java. But it's interesting. Hive came as a direct response to that, right? Trying to make Hadoop more accessible for analysts, and analysts write in SQL. But then you come to find out the whole world runs in SQL too. And so, and also, sort of a tangent, like the NoSQL movement from back in the early 2010s was fascinating because you started seeing all these NoSQL databases pop up using various languages, proprietary languages. And a lot of them have decided that, well, we should probably have a variant of SQL because, well, yeah, so it's like SQL, NoSQL or whatever. Yeah. It's just, it's a lingua franca of data languages. So it's a universal language.
And the point is, use it where it makes sense. In other words, if you have something that will work really well in SQL, then you may not want to write your own Spark data frame job to do the same thing. You're just kind of wasting a lot of time. The funny thing is that what we see in practice is that so many of these really exotic tools are mostly utilized with SQL. Even Apache Beam, which was created by Google, that now supports SQL as of just very recently. And so the other funny thing about SQL is that often it's more performant than doing it yourself because they tune it so much because everyone uses it. So, all right, so do something. Analysis models. So in this meetup, this is the part that we really care about, hopefully.
So the HBR had a really good quote. I think it's, I'll let you guys read it for yourselves. So, I mean, the pushback I'd have on this quote is I would say, like, if you're doing AI as a feature to a product, that's a bit of a different discussion, right? Like image recognition, for example. But if you're doing this to solve, if you're using AI to solve business problems, I mean, it's kind of a prerequisite that you need to know what your data looks like, be able to have analytics on it. Am I wrong in this? So, which leads you to the second point. I mean, keep saying this over and over. I mean, most companies around here are barely doing BI, let alone AI.
I mean, even in Barrie, let's be honest.
Yeah, this is true around the country, actually. Yeah.
AI, but in general, it's kind of a struggle for everyone.
Yeah. So the main notion is, analytic. I mean, it's kind of funny because in the data science community, I think like the word analyst is sort of almost it's like a bad word, right? Like it's a 4-letter word, even though it's not. So because there tends to be kind of this notion that like, oh, well, we're data scientists. We don't just look at data, we do stuff with it. And so, but I think we're starting to see like a swing of the pendulum back actually to where data analysts might be cool again. So stay tuned on that one. So analysis, what are some tools that are commonly used? I mean, how many people use Jupyter? Everybody. SQL, Spark, I'd say is sort of a good EDA tool if you have very large data sets.
Exactly. It allows you to take your like Pandas workflows or our workflows and move them on really large data sets.
Yeah. We still see R being used quite a bit. I mean, I use R as, I kind of call it the pocket calculator. Like, it's still awesome. Like, you can do everything out of the box that, I mean, basic stats at least. So, BI tools to consider. I mean, you got Looker, Tableau, and even Power BI, right? But I mean, these are kind of overlooked. But it's amazing how many times we talk to companies that, about their data ambitions, and they're still visualizing stuff in like Excel or something crazy. So
Sheets, man.
Google Sheets is, yeah. And for ADA, actually, I'm going to go out on a limb and I'm going to say spreadsheets are a way to analyze your
A
data.
lot of that.
Yeah.
If you have small data, which in many cases is great.
Yeah, I mean, actually, in the end of the world, you have like relational databases, cockroaches, and then like Excel. So
And S3.
and S3, yeah, and logistic regression. So, I mean, so the ML workflow. I mean, this should seem pretty common to you, right? I mean, you're gonna pre-process your data, train, test, validate, and ideally deploy something. But along this whole continuum is an idea of orchestrating this workload here, right? So most people don't do that part actually. They just sort of do that and this. And there's nothing wrong with it except when you want to put things in production. So and then you got to be able to deploy your model and then retrain at some point ideally and version your models and all this all the housekeeping that comes along with having stuff in production.
Well, the point is that in the DevOps world, in software agility, orchestration of code pipelines was key to move faster. So you have like tools like Jenkins that emerged to automate a lot of the things that people used to do manually that would routinely break in trying to get something into production. By automating, it became much more streamlined, much easier to identify problems. And orchestration essentially plays the same role in the data world. And especially, I mean, orchestration in data has been around forever. You have these older tools like EMX and Control-M. But modern orchestration allows you to connect to a lot more different systems and gives you a lot more flexibility.
So the cool thing is now you're starting to see sort of this interesting continuum of managed solutions, from all the major clouds here that basically allow you end-to-end EDA tools, model building tools and deployment tools, as well as versioning, monitoring, et cetera, et cetera, et cetera. And you also, you go to the extreme, you got things like Data Robot that'll just sort of do a lot of things for you as long as you have a CSV file. Zeph, Taylor's company, I mean, they work a lot on unstructured data, so video and images. And then, the cool thing is now you're starting to see like workflow orchestration, open source projects like MLflow, right? Metaflow from Netflix. That's pretty cool. And expect to see more, I would say at the top, those top two icons, expect to see more efforts of those. These all work with your major clouds down here, but the notion is it's not just enough to like write your PyTorch code, right, and do whatever you're going to do with it. It needs, at some point, it needs to get in production, and thankfully, all the clouds are not blind to this. The SageMaker is amazing. Azure Machine Learning, actually never used it. AI Platform is, I would say, the leading one if you wanted to have an end-to-end ML workflow. But the cool thing is, again, those top two icons play nicely with that. So you can sort of like write once and deploy to any of the clouds. Or there are certain situations, I would say, where I'm going to go out and totally contradict what we just said. There are certain cases where you'll want to just probably have your own hardware. There is a cost element to running machine learning in the cloud where it becomes cost prohibitive. I know a few friends who have run into these challenges, and it made more sense to put their data into a colo or their servers in there. But if you're fortunate enough to hit that point, congratulations, that's awesome. So, yeah. Okay, and that's
So this
favorite
is
topic.
I was giving a workshop on this today, actually. Well, I'll actually just jump in here. How many of you have created something like this at some point? Yeah, this is a thing that happened, right? So one of my experiences with this was I was working on a ad tech project that was using Snowflake and Databricks, and we're like, awesome, we have all these cool tools, we're gonna do really cool stuff. And then pretty soon we're like, oh man, well we need some things to run in sequence, and we need them to run in an automated fashion. So we started putting together some of these cron jobs, and then the list of cron jobs got longer and longer, and it ran on its own server. And then at some point, you'll notice Python scripts in here. One of these had a memory leak, and then just like took down the server. And I was resisting using proper orchestration for a long time, and eventually I'm like, okay, there's no other option. Like you need proper orchestration to put all these pieces together. I mean, managing this just turns into a nightmare and really ends up slowing down your deployment process.
Well, I heard a nightmare story yesterday at lunch. So I was talking to somebody, and they told me about this cron job that takes 28 days to run. I'm not even kidding. I sort of just like spit out my lunch and apologized, and then I was like, wow, that's terrible.
You said you went to proper orchestration. Are you going to explain what that was?
Yes. Yeah, I'll be getting to that momentarily.
Just code a lot of retries in, right?
Yeah, exactly. A lot of retries. Has anyone seen this cartoon before? By the way? Yeah, this is like, if you're a data engineer, or a data scientist for that matter, like, yeah, that sounds like something I've seen before.
Yeah, sorry for the icon at the top. It cuts it off.
But fundamentally, if you have data pipelines but no proper orchestration, this is what you get. You get something extremely brittle. Even if you're in the cloud where you have all this resilience and reliability and retriability, where a server can go down and you can retry, if you don't have tools to manage that, then stuff will break on a regular basis, and it also won't be scalable and manageable. And so fundamentally, you want to think in terms of a tool. This is just a screenshot of one of my favorite orchestration tools, which is Apache Airflow, but it's certainly not the only one that you can use for this purpose. And the nice thing with Airflow is that it's built from the ground up for this task. So it's distributed so that if a node goes down, you can bring up another node and keep going without losing whatever you were doing. It's designed around time partitioning of data. So you can partition data at the 1 month resolution, at the 1 date resolution, 1 hour, essentially whatever kind of time resolution you would want. It's all written in Python, and so the fundamental paradigm is that you're just running Python code behind the scenes. What's nice about that? Well, that means that I can basically communicate with any API, because virtually any API will have some kind of a Python client. It means that I can do basic data processing just right in the cluster, because people process data with Python all the time. It means that you as a data scientist or data engineer already have Python proficiency, and so you can write in a language that you're comfortable with. There are actually a bunch of these tools that you should consider. The point is to pick one that's appropriate for your use case so that you do have an orchestration layer that takes care of these issues for you.
Would you think that Beam fits into this paradigm? I mean, it does spin up a DAG, but
yeah, it's more of like, Beam is more of like a one-time pipeline.
Yeah.
Yeah, it doesn't have the scheduling aspect. But some other things like CDAP also support orchestration functionality.
Yeah.
But the idea is that you need, for orchestration, something event-based that recognizes time. So what I mean by event-based is that instead of having a cron job where everything happens at a very fixed time, you have dependencies. And so you start the whole process, and your dependency manager says, hey, what am I allowed to run? What's ready? Checks, says, okay, these 2 tasks can run. When they finish, they kick off the next downstream task. The problem you'll see with doing crons with ETL is that if you pack them too close together, what happens in terms of time? So they overlap eventually, right? Like that first task goes too long at some point, and then the second task breaks. And so you need a dependency manager that can take care of that for you. With crons, you could space them way, way far out, but what happens? Well, your ETL pipeline takes longer and longer to run. And so having proper workflow management that's event-based will just pack everything together and make it as efficient as possible. It also means, ideally, that you can communicate with anything across the cloud, as opposed to, I think 20 years ago, when you were thinking about orchestration tools, they were usually designed to just connect to one type of database. Like, here's an orchestration tool just to connect to Teradata, and we're just going to manage all of our Teradata ETL. But in the modern world, we need to think about the holistic picture of all these different APIs and different data systems potentially communicating with. Does that answer your question? Or okay.
Well, also, I think also Airflow really just it's kind of, I think I read on their homepage, it's just an orchestration tool,
Yeah.
where Beam is like a stream processing.
Yes.
Right, and not to get the two crossed over.
The question, the reason I brought up Beam was because I think that something to watch out for just in the wild is real-time orchestration tools, right? I mean, I think it's still kind of a burgeoning area. But
yeah, what I would say, so one of the fundamental confusions about Airflow versus Beam is that Airflow, it's distributed in a different way. Each individual task in Airflow can only run on one node. So when I kick off a Beam process, the whole point is that I can spin up 10 or 100 nodes to parallel process data. Airflow isn't really designed for that. It's more managed to just kind of manage the whole process and let other tools do the heavy lifting. We certainly use it for some data movement out of the APIs and such, but once you're getting into really large data, you want to offload that and do a separate tool and just use it to manage all the pieces working together. One thing I'll point out is that this is another area where managed services are really nice, because to realize the power of one of these orchestrators, you need something distributed, and distributed systems is hard. And so Google has a product called Cloud Composer. Astronomer.io offers a version of Airflow that they support. Google has one, although it's only single server, so it's not quite as sophisticated, but it can still do quite a bit of the work for you.
so, kind of circling back, teams. So how many people know what Conway's law is? So it's a pretty important rule, and the gist of it really is like a company is going to design systems around the way that it communicates, right? So how many people work or have worked in siloed companies? Like a lot of people. So how did that work out in terms of getting the data you needed to do your job as a data scientist or a data engineer? Is it easy? Hard? So I mean, think about Conway's law with respect to your teams as well, and how your team interacts with other teams. I would say this is like one of the most fundamental things you need to consider, actually. Like, as we started noticing, I think Conway's law just kept getting it beaten to my skull. So like,
So for example, one of the things we'll see is that you have an EDW that's kind of from the older part of the business, and you have a Hadoop stack that was meant to do big data when it was really hot things. And the two teams don't really communicate with each other, right? Like they should be working kind of in the same domain at different scale, but they don't want to share their data with each other.
Mm-hmm. Yeah, so that it kind of, and how many people have heard of like the acronym HIPPO, like highest, what is it? What's the I stand for? I can't remember.
I think HI is highest paid person.
Yeah, highest paid person's opinion. So,
Highest individual.
Yeah. I mean, think about this in an organization, right? I mean, if you guys are working on a great data orchestration framework or a great model that's just going to change the business, I mean, at the end of the day, this person, I mean, if the company's still ruled by that person or those people, good luck. So it kind of doesn't matter. How many people have come across this? You don't need to raise your hand. So, we're all friends. So I mean, on the framework, we tend to look at things anymore as like technology. Strangely enough, for an infrastructure company like ours or our company, it's like the last thing we consider in a lot of assessments of problems, because it's about people, process, problem, and then technology. Technology is the easy part, actually.
Well, often we do project-based solutions with customers, but you have to find the person who's going to drive it for you.
Yeah.
Right. You have to find
All the
someone
time.
who really owns it.
Yeah, so I mean, I can't count how many people are in the graveyard of like data scientists that like show up on the job day one, like I'm gonna kill it, I'm gonna get like, some model building and all this stuff, and like 12 months later they're disillusioned and looking for other jobs because they didn't get the support they needed, from the organization or from other teams and so forth. So just something to keep in mind. I mean, it's a touchy-feely subject, and I know that people have an aversion to it, but you can't ignore it, and you ignore it at your own peril. So, some suggestions for teams. Big one. Organizational alignments. Even if you have an exec or a hippo or whoever that's going to sponsor you, it still doesn't matter if the people that are in charge of supporting you don't care. There needs to be alignment from the top down and bottom up. Silos kill data. Organizational silos are where like data and data scientists go to die. So, I mean, I'm not saying that you may have the power to break down silos, but at least talk to your boss or an executive about maybe some ways that you can achieve that. Because if you have silos, it's just going to make it like a million times harder for you to do your job.
Yeah.
It's as simple as that.
Also, pay attention to the difference between engineering and business, right? That's one of the most common walls we see. Really great engineers, you have really great business people, but they don't communicate effectively.
Mm-hmm.
And so the business people are frustrated and like, why can't engineering get us what we need? Well, there's somehow a breakdown in communication there.
And I think a lot of it comes from like, non-technical people still think of techies as a cost center, right? And it's like, oh, you guys just cost us money.
We're all costing our companies money right now.
So, I mean, it needs to be reframed, though. I mean, it needs to be solving problems that provide real value to the business. I mean, that's why you would get hired in the first place, right? In a great theoretical world that doesn't exist. But the point being, if you can work with business and help them understand that you're actually creating value with data. I mean, we live in 21st century now. Data is the hot commodity and all that. So why the hell do these divisions still exist? So, and also finally, don't weaponize data. This happens in silo organizations a lot, where data in one department. How many people have had this happen where you have like different data sets and nobody can agree with the ground truth of the data is, and you have turf wars.
Yeah, I've seen cases where people are organized, they're accusing other executives of falsifying their data. That
Happens a lot. And at that point, I don't know what to tell you. Go get a job as a gardener or something. Be a lot more.
But hold on, how do you not weaponize data at all? I remember John telling me once that he worked for a guy who said, "We're moving steadily on all fronts. We're moving forward in every direction." And obviously, the purpose of the data is to convince the company to stop spending money in the wrong places and focus in better places.
Yeah.
So in a certain, I mean, how do you do that diplomatically without?
The point is to have enough communication so that people can trust each other's data. In other words, you should not maintain two versions of data about the same thing. You can have data that says, let's go in direction X or direction Y, or that favors one part of the company over another, but they should all be relying on the same version of truth. Like, you should not have separate analytics or ETL teams doing their own work and getting different answers. If that's happening, then you need to do some major assessment at the top.
Our advice too was like telling people to like floss their teeth every night, right? Like nobody's gonna do it, even though it's a good idea, and it'll help you like have better hygiene, because it's hard, right? I mean, at the end of the day, you're dealing with people and their motivations. Like Charlie Munger, Warren Buffett's partner, has a really good quote, which I always think about, like, show me an incentive and I'll show you an outcome. It's as simple as that. But again, when you think back to the jobs you do every day, I would say these are the things that should be in the back of your head, because like you will succeed or fail based upon things that are sometimes out of your control, actually. But it's something to keep in mind. Yeah.
Yeah, related to don't weaponize data, and I'm an aspiring data scientist, but I get involved once in a while, and I do understand that you're trying to tell a narrative here, and depending on the audience, you'll leave stuff out and you intentionally, because you can't put everything in there. And then you'll have my peers, techies, going, well, this can't possibly be the whole story. And I go, no, it's not. This is, the consumers of this are executive staff. They're concerned with the pain of the customer, not all the minutia that we know about. So you're leaving stuff out intentionally because you have to tell a story. I said, does my story prevent you from getting your job done? Like that was sort of because yes, we're the experts on this, but do they want to know every packet that went through this server? No.
I used to be like that kind of person too that would just spew all sorts of stuff to executives. And I remember an executive had told me once, like, look, when I ask you for the time, don't tell me how to make a watch, just tell me the time. So, and that was great. It was like getting slapped in the face, and it felt great. And since then, I think to your point, right? Like it depends on the audience. Some people want a lot of facts, a lot of detail. Most business people could care less, honestly. They just want to know, like, what do I need to do next?
They're only going to spend 10 minutes on this at most, and then they're going to move on.
Yep. Yeah. So, and you know, I was actually talking about this with a client the other day. Like, they were asking, oh, so you know, data, like, we have these data scientists, but you know, what kind of question if they can communicate with business people? I was like, well, probably want to. I don't know. It's a skill that you need to teach because at the end of the day, all data is storytelling. You know, I mean, from a business perspective, obviously you can use data for other things and use outputs, but it is storytelling.
Truth, but you're telling us the story.
Yeah.
I think our big thing is that what we see is that you have data quality problems that go undiagnosed because there's no culture of accountability and communication, and also a culture of just fixing things that allows that to happen. So you need to make sure there's a culture that fixes data quality issues, and you need to maintain data consistency across the
Well, we always say that data is a silent killer, right? Like an application, like, you know, you have like test-driven development and those sorts of methodologies that'll catch issues in an application before you release it in production, hopefully. With data, it's a lot harder, right? Because you could release a report, or you know, you could make a report that's based upon data that you find out is false. We've seen this happen where like people are making decisions on data that's been wrong the entire time, and then the default answer is, oh, well, as long as it's like consistent, it's like we're fine. Yeah. so that's a cop out.
Because I put draft over.
Yeah.
Didn't see anything. You know,
Sure. It's like, well, at least the trend's like, you know,
I did the big
things are going up, right? I would say this results in things like audits or like companies going out of business in some cases, you know, in dramatic cases. So again, it comes back to communication, right? I mean, it's again, it's kind of strange we're at an ML talk talking about this, but I mean, you'll thank us later.
And what I would add to data quality is that the data engineers, the data scientists, and the analysts know where the bodies are buried. Like usually they're the first ones to sniff out a data quality issue. Mm-hmm. So the question is, how does your organization respond when they bring this up? Do they shoot the messenger? Do they just tell you to shut up? Or are they like, oh, we need a process to go fix that problem? And that's what creates quality data. That's what creates consistency. And that's what prevents like weaponizing between different teams that have data.
But that said, sometimes some companies are totally broken and then you can't help them. So you probably should go somewhere else. It's just a fact. Don't shoot the messenger. Best practices. So security and privacy are a big thing these days. I mean, breaches happen a lot. And, I mean, governments are regulating data. Governments are going to start regulating machine learning models pretty soon. In the EU, I know they're actively looking at regulations. I think that they're due by the end of the year that are going to hold companies accountable for the models that they produce, right? So I should say ethics also comes first in this, but I forgot to put it in. And it's still kind of an ambiguous thing as well. You're starting to hear more about AI ethics, but like, yeah, I mean, my question is like, whose ethics? So, but anyway, these are being regulated. You got to think about these things because there are serious consequences. It's not like the good old days, I say that jokingly, of course, where you could just sort of willy-nilly throw up a model behind like an unprotected Flask REST API and just have your way with things. The world is a dangerous place. think of security and privacy first, especially when you're deploying things in production. Make sure you're using HTTPS endpoints, not HTTP. Kind of goes without saying, but it's kind of surprising how often that happens. Unencrypted public S3 buckets happen a lot. I wouldn't say a lot, but it happens more than it should, which should be zero.
Every time there's a big data breach, it's an unencrypted. It's like a public S3 bucket.
Yeah. Or like you got an EC2 instance and like port 22 is open to everywhere. So people can just SSH in and have fun with your server. These things happen a lot, and I would say that's where the bridge between like a data engineer and a data scientist is really important. Right? Like work with, or sysadmins even, like work with people who are good at putting things into production. Better yet, rely on the cloud and third-party providers to just do it for you. I mean, that's their job. So yeah.
Do you guys have anything in regards to your labeled data? Like, do you do any NLP or stuff where you actually have text that might have, like, let's say you're going to train a model for NER or something, right? Or whatever. So you got to have real stuff in there. And some of the stuff you can take out, right? So, but there's other things like names and combinations of that, and stuff like that. Privatizing that and making it less real than what it really is. And so I'm just wondering if you guys have ever run into that case where you need to version your labeled set, and the labeled set might have some data in there.
Yeah, I mean, so we do run into, I think this problem. It's more on the structured data end of things, I would say, but I think the point is still there. And so there are some great tools, I would say, that you should leverage. Like Macy, I think from Amazon does some of this, and then Google's data loss prevention tool will actually scrub your data and like automatically go through according to rules. So because at a certain point, like if you're trying to run a script against it, you're like resources.
Well, I guess what I'm talking about is it's labeled data. It's you want it to be real, right?
So you need to clean
the labeled data.
Yeah. Yeah. What are your thoughts?
Yeah, I mean, this is still a really hard problem at the moment. So I think some companies have solved it, most have not. So this big issue is one that a lot of people are thinking about at the moment.
Yeah, I don't really have an answer for that one yet. And unfortunately, it sucks because you're still held accountable to it by the laws, right? So.
Well, and the crazy thing is that like for GDPR, someone can contact us and say, I want my name removed from this. It's like, well, you were in my labeled data, but I randomized the labeled data, but now your name still shows up just by happenstance.
Yeah.
Right?
It's a tough one. I mean, because you have to go call through all the embeddings and everything.
Even though it's not really legal, that's not really their name. Right. It's just that combination of the first and given name show up. So what does that mean?
Yeah, and especially now that you're gonna have to have the same thing with the actual models. It's like, yeah, I don't know. This is one of the weird things with the regulations right now, right? It's like real world examples like this. I mean, there's not really a good answer for it. I mean, I'm not gonna sit here and like make something up. So it's just, but this is, yeah, it's a tough one. So. Hit me up after this, though. I'm going to do a bit of homework and see what maybe our friends over at Google are doing. So, yeah.
But we ran into one company that was like, I think they had an intern write a Python script to do this, and then it would run on one server, and it would take like several 8 hours to run or something to try to scour their data. So it's not a solved problem.
Well, a lot of things I'm going to use it for is to scrub the data. Right? Yeah. But you first have to have something that has the data so you can scrub it.
And then you have to have data lineage in order to know what you need to delete. So yeah. Agile pipelines. So
yeah, agility again. Just think of agility in software development and try to apply the same concepts in the world of your data pipelines. And fundamentally, cloud is key to this because in the past, one of the key issues you run into is you couldn't really create 2 versions of a table because your database just didn't have space for that. Well, if your data is stored in cloud storage or S3, then you can have a lot of versions of tables. And so in many cases, you want iterative versions of data sets. And you don't keep those forever. You need a cleanup process where you really will have too much data, but you can't temporarily have a fork of something to see if the new version is cleaner or works better for a data science model, or it just fixes a data quality problem, but you have downstream stuff that needs to be fixed before you can cut over to the new version.
The names escape me, but I know there's a lot of active interest in the open source community on solving this problem right now. So talk about bottlenecks, organization, technology. Bottlenecks inherently get in the way of orchestration, so this should seem almost like a tautology. Domain expertise trumps credentials. Tell me I'm wrong.
In particular, this means things like if I'm a data scientist. I think for a long time there was the attitude that I'm a data scientist, I don't want to talk to the business because that will contaminate my thinking. But usually talking to the business is going to get you way ahead on solving a problem. Like there are actually people who understand this data pretty well and can tell you some of the details of how it works. So for example, if anyone's dealt with the Google AdWords, they have all these different rules for how bids work and how audiences work. And those rules keep changing. If you as a data scientist want to run out there and try to learn all those, like good luck, but you can just bring in someone who's already really good at that stuff and you can focus on what you're good at instead.
Yeah, and I think back to your point as well. It's well, sort of your point. To understand your data, right? But yeah, there's definitely some complexities I think you bring up that definitely are still, I would say, TBD. But in general, data governance, data cataloging, and lineage is becoming, I would say, a very key thing in the data stack right now. It's no longer just something that you do because, well, I was going to say because you want to, but nobody actually wants to do this. But you have to. And as data keeps growing, it's just a good habit to get into. Marquez is actually a really good open source tool you can check out for cataloging and lineage. There's also Google's data catalog is another one. And then any pipeline tool you use, I mean, there should be a sense of lineage, right? It's being able to track your data assets. The problem with that is, of course, is that now you're stuck in your pipeline tool. So you want to leave. But I think this is people are starting to address this problem left and right. Is even a local company, a local group doing Great Expectations? Have you heard of them? So there is a data quality open source tool. I would say check them out. Data cataloging, data collaboration, data quality. They're doing some awesome things. You had a question, right?
Yeah, so on a high level, what does data governance include? What is it? What is the main for your in your interpretation? What is it? What should that be?
Yeah, I mean it's a good point. I think it could these could be the catalog and lineage could be a subset of data governance actually. But at the end of the day, it's knowing like what data you have and where it is. Is basically how you would describe it. I mean, there's a lot of different tools out there. Like Calibra is one, and there's a bunch of others that I think are data governance tools. But they all sort of do different stuff, right? So I mean, there's not really a standard definition yet. Unfortunately, it's interesting because like these data cataloging tools, some of them have been around for a while, but I'd say that the field of like data governance is still super early. But and if this is something that interests you, I would say this might be one of the waves of the future is actually getting into this space. It's necessary. You as a business will probably like be running afoul of the law for one thing if you don't have these in place.
I would say as well, I mean, in addition to just knowledge of what you can have an accountability organization, not a full like top-down command and control management structure, but more a forum for communicating about data issues. That can be a core part of your data governance. In other words, understanding what the data quality issues are and how to fix them.
And there's other cool stuff too. What was it? Airbnb had a knowledge repo, I think it is.
Yeah, it's data portal. They have a
Data
blog post
portal,
about
yeah.
that. That's
It's ways you can share all your like. Well, knowledge repo I think is where you can share your GitHub repos with people internally, right? Your notebooks and stuff.
Okay.
Yeah, but then there's Portal as well, which I think addresses that. Yeah, Airbnb, they do a good job at like making these great articles about all the cool stuff they developed in-house and they don't really share it with the rest of the world. Except for Airflow, yeah.
But yeah, the idea with Data Portal is that Airbnb created this social layer plus a data crawling tool that would just look at everything that was out there and create a graph of how the data sources connected to each other. And then people were expected to post comments on their data that explained what that data was. And people could post questions and the owner could then post answers to those questions. That's like a very democratic approach to data governance. But I think every company that has a lot of data sources should have something like that, whether it's a social layer or just maybe a committee that communicates with the other teams about what data is out there, keeps track of it.
Well, because the opposite really is, remember one company, they had like all these data sources, but the thing is, nobody knew what they were because all the people who had compiled them or the scripts that created them, they all had either retired or died. So, like, how would you be able to make sense out of this data? I mean, we were brought in to build a data warehouse off this data, and like, so what does any of this stuff mean? Nobody knew. So.
Yeah, like the field names were what, just like 8 characters?
Yeah, it was off a mainframe, like a 1980s DB2 database. So like the characters were restricted to 7 for the column names. So there are all these cryptic ones that you could make no sense out of. And yeah, so I'm just like, I don't know.
The point is, even if you're in a modern data structure where you have reasonable column names, it's good to post some documentation about what your
Big
data
time.
is.
Oh, and the killer on this one, the icing. You guys have heard the expression like the bus factor, right? Like somebody gets hit by a bus and they're no longer there. Well, the guy who was in charge of the mainframe, he didn't document his code, was very secretive about what he was building. And then one day, I guess, over several days, he didn't show up for work. And you find out that he actually died. So like, this is like their entire company runs on this order system that he was maintaining. So document.
It's less morbid. You might leave your job someday.
Yeah, especially given the tenure of most jobs, what is it, like 2 years, or in tech, like 2 days or something. So again, think pipelines first, and then we're Ternary data. Contact us. So, any questions? Yeah.
So one thing you didn't address explicitly, I'm interested to hear your feedback on. So I spent a good amount of my time just meeting with data science teams around the country. And it seems like they're all kind of in this one of two boats, right? They're in terms of this pipeline. It's not like they're unaware of these different elements of the pipeline, right? But they're kind of, if they're in the decision-making process, they're kind of just overwhelmed with the sheer number of choices. I mean, it's been a few years since my Common Works days, but I mean, just the number of combinations of the tools you've listed here is just kind of overwhelming. So there's kind of a FOMO, a fear of missing out, or a fear of getting locked in, right? So then on the other side, those who've already made decisions, I don't know if I've ever met a single team that says, oh yeah, we love everything that we have. It all works really well together. So I'm wondering, just your feedback on that, on the technology, choice part of the process, right? Tips for managing that well and proceeding that through that in an effective way.
That's a good question, because I think resume-driven development and like fear of missing out, those are both huge problems in tech, whether you're a data scientist or software developer, right? We often see people rolling their own way.
Especially the resume-driven development part. That happens a lot. Because it's especially in the data world, right? It's like every day there's a new framework that comes out. I encourage people to spend maybe 10% of their time or whatever made-up number experimenting with new stuff. Always be learning, because there's always something new coming out. Learn new paradigms, but. That said, it's sort of like, I guess my take on that is it's the old Amazon, or actually it was Intel, really, like disagree but commit at some point, right? Like we may agree and disagree on the approach we're taking with technology, but at some point we're going to commit to this path, and that's kind of how we got to do it. Because otherwise you have like chaos and, but you have to couple that though, I think, with an idea of continuous learning. So the data keeps changing all the time, at least best practices. And if you're stuck in the past, then you have that much farther to catch up. It's interesting. We see this with companies around here that you would think are, I would say, like really savvy in their data stacks. I mean, they'll say like we feel like we're several years behind in what we're doing. Wow. Are you getting your job done, right? Like, are you doing the things that you were tasked to do? Yes. Could you do it better? Probably. So I don't know if I answered your question.
It's a hard problem.
It's a really hard problem.
Sometimes the situation can be improved by just somewhat better management, and by that I mean that you need product managers who are tech savvy enough to make good product technology decisions. And decide, okay, our team, here's a good technology. It's not the shiniest object that we could be using, And you also need product managers who really communicate effectively with their team and maybe can sniff out the difference between just grabbing the latest, shiniest thing and good technical advice. I often see a real wall of separation between the people managing product and their tech team, and that either means that the tech team will kind of run wild on technology, or the product manager will arbitrarily make a decision without them.
You also see this weird like bait and switch thing with hiring managers too.
Yeah.
Like, because they want to attract like the best talent and little money. But I mean, if you look at job postings, for example, right? I mean, they're always trying to like put the latest, greatest tech, data or tech stuff on there just so it'll attract applicants. And I can't tell you how many times it is where like you talk to the people who got hired for these jobs and they're doing nothing of the sort. They're sitting there like cleaning toilets or like just doing something like entirely not related to the tech stack that they thought they were getting hired. It's a bait and switch operation, but this happens a lot. It's a honeypot for nerds. So, so that's the other piece of it, because employers know that everyone wants to learn the cool stuff, but then when it comes down to actually implementing it and saying, "Oh, we're going to do this cool stuff," I mean, it's got. I think it's got a big success rate. You can talk to people around in the data community. This happens, I would say, not infrequently. But that said, good teams, I think, are always trying to keep one step ahead of the curve. There's the old like Stuart Brand comment about the steamroller of technology. Like you're either staying ahead of it or you're getting mercilessly crushed by it. And like technology doesn't really carry the way. So.
You have an opinion about how to approach?
Yeah, I'm curious what you
it's a really hard opinion.
The most successful companies I've seen have a really strong chief analytics officer or chief information officer or both, right? Where they're just kind of, they're visionary, but they have good leadership skills as well as good analytic skills. And so I think it comes back to, strong leadership, but I still see a lot of groups just struggling with those choices.
Yeah, I think it's a really good point. Leadership is it's a lot of it, right? So it's a really good point. But do another question?
Well, I'd say one strategy when you're interviewing, you should also take an inventory of the sacred cows and where they're exploits and that kind of, you're interviewing them too. But anyway, can you live with those sacred cows? That's something you need to ask for you.
I have a different question. So for breaking down silos, when is it appropriate to group teams by skill set or group by product? So do you have the data engineer and the data scientist all on the same product team, or do you have all the data scientists on the same team?
I would use Conway's law to determine that. Like, what's going to be a reasonable fit for the company, right? And how it kind of operates. You're not, it's sort of like otherwise, if you have like a weird fit with the team, the host rejects the organism, so to speak.
Are there trade-offs that you can think of?
I think if you look at the difference between Amazon and Google, and if you really understand AWS and GCP services, you can kind of see the strengths and weaknesses of these different approaches. So Amazon is really famous for pizza box teams, and that has created a lot of really great services.
What does that mean?
So meaning that you're supposed to have a team that's small enough, like you're talking about fully integrated teams that's small enough that you can feed them with like 1 or 2 pizzas. So it shouldn't get a lot larger than that. And they do the cross-functional team. In practice, what we see with a lot of AWS services is they're really solid, but they're not super integrated. Like each service kind of seems to be its own thing. With Google, you have these like services that do play much nicer together, but it's taken Google a lot longer to catch up with AWS, let's be frank. Like they have not moved as fast. They have really great services.
Talk to people at AWS, they tend to run things more as a startup within a startup within a startup. And a company like Google is the opposite. So, but again, it's that edict was at Amazon was bestowed upon the organization by Jeff Bezos himself. So it's kind of how it rolls. Google's different. So I guess I don't know that there's in one answer to your question. It's classic. It depends answer, because it really just depends. I mean, it's back to Conway's law. That's Google and Amazon have different structures, and that's going to reflect how you organize. If it's a skill set versus a product. Like we were talking with one company about how they structure their data team, and it was the thing that we had suggested really was more of a hybrid approach where you have a head of data, but then you have data people embedded into each department, really, with a strict line back to that head of data. And the reason is, if the data person started reporting to maybe the VP of that department, then you have siloing potential and Stockholm syndrome. So we recommended that was one approach, maybe a dotted line to the VP, but a straight, very unambiguous line to the head of data, because that person is going to, I think back to the leadership point, right? Like that's where your standards are going to come in. Because otherwise, I mean, Lord help you, you're going to have like code chaos and no standards whatsoever, and everyone doing whatever framework. And,
even Amazon does something like
Amazon
this.
actually does this.
Yeah, so what they do, so you have these cross-functional teams, but their assumption is that no one on any of those teams is truly going to be a database expert, for example. They'll have a database person who's also a software developer. And so they have kind of these internal consultants who go around and help the teams and maintain standards according to what AWS has determined best practices are for web applications, for example. So yeah, it seems like, I don't know, a lot of companies are settling on a hybrid, because if you go to one extreme or the other, you run into some kind of problems. But yeah, it's, I don't think we have the answer necessarily to that one.
That's helpful. I hadn't even thought about like the hybrid stuff.
And in fact, that's what we've also found in some cases when we talk to clients. We've suggested like an accountability-based model, kind of like what Joe was talking about. So get away from command and control, but you have these dev teams whose data gets consumed by analytics teams, right? So you have the head of data like he's talking about, and they're at least accountable to that head of data. In other words, if something breaks, they need to explain why. They really should be documenting their work and communicating with other people. And the head of data is there to make sure that happens, and that people have have a conversation if something goes wrong.
It's kind of like two accountability lines, one for the product and one for like your specialty, whatever that is.
Exactly.
So, I mean, Spotify does this, right, with their guilds and chapters kind of model. So in that sense, it's like, and in fact, we did this at one company I was at where Spotify, I don't know, how many people are familiar with this model of?
We do.
Okay, it works.
Very effectively.
Yeah, I think it's a great model, actually.
It works very effectively for product focus that and we've been able to quickly push products out that way.
Yeah.
And so now the question we're coming to ask and follow up and answer with that is the idea of data governance and data ownership. Right now, each team owns its own data, which is great, but you have to consume data from other teams. So we're moving forward to address that, but it works really great for the software product.
Yeah. And that's really where it started, was in the software. So the idea really is you would have like front end, back end developer in a specific product, for example. But then I can't remember if it's chapter guild or whichever. But anyway, the front end devs in each product are then responsible. They're cross accountable to a chapter head, for example, of the front end. So I mean, something similar could work with data. I think it's. There are, I would say, some differences between software engineering and data.
So one thing to be aware of is like Pluralsight was very, very good at that siloed product. They were isolated down, and now, I don't know, I haven't talked to them much, but it sounds like they're having a lot of struggles then trying to do overarching data architecture or data structure, because each team had total control. There was no coordination or planning.
So one of the things we suggested in one of our discussions was that, like Mariah